Hi class, welcome to another lesson. What I want you to do right now is I want you to take out your notes from yesterday. That is the Advanced Algebra A 2.6 notes. It has the greatest integer or step function at the very top. We graphed these piecewise functions yesterday, 2, 3, 4, 5. We graphed those. Now we haven't finished them because we haven't done the set and interval notation yet, and that's what we're going to do right now. So you should have already watched the video on set and interval notation, so we should already have a good understanding of what that is. So for number 2, we graphed these yesterday. Everything in red was what we did yesterday. And so this part and this part, we did this yesterday. So that should all make sense to you. So we've already concluded that those red lines, that is a picture of this. It's a piecewise function, which is two different lines that have restrictions on them. Now we're going to explain what x and y's do exist. The domain, those are always the x variable. Domain is the x variable, and the range is the y variable then. Okay? So whenever we deal with the domain, what we deal with is this x-axis. And then obviously whenever we deal with the range, we deal with this y-axis. What I always do, you have to do all four of these, the domain and the range for the set, the domain and the range for the interval notation. You have to do all four of those, so it doesn't really matter. I always like to do the interval notation first. So I always start with this one. And so it might be something that you kind of get into as well, just because I always do it that way. But just to let you know, you can start with set notation and then go to interval. Either one is fine. But I always start off with the interval notation, which, remember, that's the one that uses parentheses and brackets and stuff like that. All right. What we're going to start off with is I want to know, with this green line, this is going to determine my domain. Okay? Because that's going to determine if I have a value on my x-axis. So I guess I ask you this question. Whoops. If I move this green line right here, at anywhere, does it touch the red line? Yes, it does. It obviously touches right here. So it has an x value. Does it touch my graph? Does this green line touch any of the red right here? Obviously, you'd say yes. There is then an x value right here. That x value is maybe a negative 1.6, just guessing. If I move it over to here, is my green line touching the red one? You would say yes, obviously. It touches right here. So what x value is that? That x value is right here, which is a negative 1, 2, 3. A negative 3. So what I'm going to do, class, is I'm going to tell what this graph exists of using set and interval notation. So this green line, it touches all this red, and you always start from left to right. So does it touch anything red over here? It doesn't, but hopefully you see that this arrow means that it goes infinitely down and to the left. So if I extended it forever and ever and ever and ever, obviously I can move this green line left forever and ever and ever and ever, and it would always touch that red line. So where does it start? It actually starts at negative infinity. It goes forever to the left. So at negative infinity. Remember how a parenthesis always comes before a negative infinity. So now as I go from left to the right, when does it stop touching the red line? It touches right here, doesn't it? Just as far as this one is concerned. It stops touching my red line when I get right there. So it goes all the way up to 0. But now notice, class, what happens. It's now touching my red line up here, isn't it? This means that it can equal 0. Open circle means that it does not. Closed circle means that it does. So now it does touch it again. So if that's the case, it is continuing to go from left to right. From negative infinity, it goes and goes and goes, and now it jumps up to here, and it continues to go to the right, to the right, to the right, to the right. For how long? This red line with the arrow on it means that it goes forever to the right, doesn't it? So if that's the case, this green line goes forever to the right, and this is telling us that it goes from negative infinity all the way to positive infinity. X can be any real number. It can be anything from negative infinity all the way to positive infinity, so there is no restriction. X is all real numbers, which in interval notation is done from negative infinity to positive infinity. All right, so now with that being said, let's talk about our set notation for the domain. If it goes from negative infinity to positive infinity, which means it's all real numbers, we say that X such that X belongs all real numbers. And now you're done for this domain for the set notation. X such that X belongs all real numbers. So that is how you do the domain. For the range, you take this line and instead of vertical, you're going to now change it to a horizontal line. And you're going to do the exact same thing. You're going to go from the bottom up. Does my graph have everything down here? It touches, it touches, it touches, it touches, and even right here it still touches, right? Because your graph is going to continue going down and down and down and down. So it's going to start once again at negative infinity. Now, do we stop at some point? I still have a y value, I still have a y value, I still have a y value. What I mean by that is here is a negative 2. Do I have a y value of a negative 2? Yep, I do. It's right here. It's at a negative 2, negative 2. My graph does have a y value of a negative 2. It is right here. And we can do that for all of these. Negative 3, negative 4, negative 5, negative 6. So we have y values for all of these. But when do we stop having y values? Right there. That open circle means that I do not have that my function does not exist at that point. And so because it's not equal to 0, I put a parenthesis. Now, are these the only y values in my graph? Do you see any other red besides just down here? And obviously you say yes, right? There is another red line right there. So I have more y values. My y values are right here. So when I have more y values, I have a union. Remember how we have that union? And now what other y values do we have? My y value is at a positive 2. This is 1. Here's 2, 3, 4, 5, obviously, right? So at 2 I have y values. This line has no slope, right? It's not going up and to the right, so I don't have a y value of 3, of 4, of 5, of 6, so on and so forth. All I have is this y value of 2. It stays on this the whole time. So I have a union. What other y values do I have? I have a y value of 2. And if it equals 2, class, you're going to put a bracket around that 2. Because brackets mean that it can equal 2. So if it is less than or if it's greater than, you put parentheses. But if it equals 2, such as this one, that means that you have brackets around that. So your interval notation, it goes from a negative infinity all the way up to 0, doesn't include 0, and then it picks back up at 2, and it stays there. So union 2. So for my range, we always say x such that, or for my range, it's the variable y. So y such that y, is it greater than or less than? What does y consist of? Y is everything less than 0. Look at the graph here. Everything that my y exists for is below the x-axis, so it's below 0. Negative 1, there's a value. Negative 2, there's a value. Negative 3, there's a value. Negative 4, there's a value. It goes down and to the left. So it goes all the way to negative infinity. There we are. It goes all the way to negative infinity. So my y is less than 0, and that's where I get this coming from. It's not less than or equal to because I have an open circle up here, so it's just less than 0. Now I have more y values, so I say or. I also have a y value of 2 like we talked about. Or we say y equals 2. So y is less than 0 or y equals 2. So this is what I expect from you on a test. It's not easy right now. I think the more that we do of this, the easier and easier it is going to get. All right, let's try number 3. So we're looking at our graph. from left to right, we do the domain first. So if we go to the left, to the left, to the left, we still have x values, we still have x values, we still have x values, and that arrow says that we go infinitively to the left. So if it's infinite to the left, it starts at negative infinity. So my domain for my interval notation, it starts at negative infinity with the parenthesis, and how far does it go? It stops right there. What x value is that? Well, I could tell you that that point is at a -1, +3. So if that point is at a -1, +3, my x values go all the way up to a -1. So it goes from negative infinity to a -1, and then it stops. It has an open circle, which means it does not include it. So if it does not include it, we use a parenthesis. Now, we're going to have more x values, so we have a union. Where do my x values pick up again? There's no x values in here, but my x values pick up again at this point. This point is at right 1 up 2. So my x value, it picks up again at 1. And then how far does it go to the right? It goes all the way to positive infinity. So it picks back up again at 1. It doesn't equal 1 because there's that open circle there, so we're going to use a parenthesis, comma, and we're going to go all the way to positive infinity. So a negative infinity to 1, union 1 to positive infinity. How do we explain that in set notation? We say that x such that, and now we know that x is everything left of a -1. It is left of a -1. So that means it's less than it. X such that x is less than a -1. It's not less than or equal to, it is just less than a -1. But we have more x values, right, because this also goes up and to the right. So we're going to say, or x, it's bigger than, it goes to the right, it is greater than a +1. Or x is greater than a +1. You're not going to have greater than or equal to, it is just going to be greater than. So this is your answer for the domain on set notation. X such that x is less than a -1 or x is greater than 1. All right, for the range, let me get rid of some of this garbage up here that I've written. For my range, I'm now going to have a vertical line, a horizontal line. Do you see any red down here? I do not. So where does my red start? Going from the bottom up, it starts right at that value of a y value of 2. So it starts at 2. I ask you the question, does it include 2? And hopefully your answer is no, it does not, because this is an open circle right there. So it doesn't include 2, so you're going to have a parenthesis right here. And now how high does it go? It goes here and up and up and up and up and up, and it goes all the way to positive infinity, right? It would continue to go up and up and up and up forever and ever and ever. So it goes all the way to positive infinity, so we have 2, comma, positive infinity, because that's how high it goes, and infinity is always ended with a parenthesis. You don't even really have to worry about this. This is a y value of 3, but when you say 2 to positive infinity, doesn't that include the y value of 3? Of course it does. It includes 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to infinity. So you don't even have to write union, it also equals 3, because that's already included in this part. So then your set notation, instead of x such that x, you say y such that. What are the values of y? They start at 2, and then they go up and up and up and up forever and ever and ever. So it's y such that y is everything bigger or higher or greater than the y value of 2. Y such that y is greater than 2. All right, hopefully 3 was easier than 2, and now hopefully 4 is going to be easier than 3. Starting with our x values, our domain. We go from left to right. Do I start at a negative infinity? Yes, I do. This continues to go down and to the left. And it will forever and ever and ever go down and to the left all the way to infinity. So we start at a negative infinity. We always have a parenthesis there. How far to the right do I go? I go all the way up to a -2. And it does include a negative 2 because this right here is a closed circle. So I go there, and now just on the other side of 2, which would be like 2.1 or 2.2, that's down here. So I also have x values greater than 2 right here, and it goes up and up and up to the right, to the right, to the right. So my green line, it goes from a negative infinity all the way to a negative 2, and then it stops up here, but it continues down here. So what does that tell you? Your green line continues to go on red, on red, on red, and red, and this red arrow means it continues to go up and to the right forever and ever and ever. So it's going to continue going to the right, to the right, to the right. It's never going to stop, which means it goes to positive infinity. So this one goes from negative infinity, and it doesn't stop. It goes all the way to positive infinity. There's nothing that x cannot be on this one. Negative infinity to positive infinity. So for set notation, we say x such that x belongs all real numbers. All right, now for my range. My range, we're going to turn my green line, to a horizontal line. And now, this red line, it goes down and to the left like we talked about. So it's going to go down and down and down and down forever and ever and ever and ever and ever. It's going to go down. So it's going to start at a negative infinity. And now let's talk about how high it's going to go. So it starts way down here, and it goes up and up and up and up, and it continues to go up and up and up. And this one is forever going to go up and up and up, and it's always going to go up. So it goes all the way to positive infinity. Remember, with our infinities, we always have parentheses. So our set notation is basically the same, except now it's y's. Y such that y is from negative infinity to positive infinity, which means it belongs all real numbers. There we have it for number 4. Number 5. You see our graph. My green line here, is it going to cross the red as my red line goes up and to the left? Yes, it will. And that red line will continue going up and to the left, so negative infinity is where I'm going to start for my domain. How far to the right am I able to go before I have to stop? I go right, 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 and I have to stop right there, don't I? Because it does not include my x value of 0 right here, because that's an open circle. Nor does it include my x value of 0 right here, because that is an open circle. So I have to stop at 0. There is no x value of 0 in this graph. However, I've just done all of these x values. I haven't done any of these ones. So what do I need? I need a union, because I have more x values. I am going to start my x values going from left to right just on the other side of 0. So going from 0, it doesn't include 0, so I'm going to use a parenthesis. And how far to the right is my red line going to go? And hopefully you've gotten the gist of forever, all the way to positive infinity. And you're going to have a parenthesis there. So for your set notation for the domain, what does your x value include? X such that x is all the numbers that are less than 0. X such that x is less than 0. But isn't it also all the numbers that are greater than 0? All these numbers also work for x, which is the ones that are greater than 0. So we would also have or x is greater than 0. All right, and now you have the range left. So if we look at the range, we're going to turn our line. You guys can do the exact same thing. You can get a pencil or just use your finger or something like that and have a vertical or horizontal line. For the range, we're going to have our horizontal line. This red line goes down forever and ever and ever and ever. It's going to go through the floor. It's going to go through the Earth's crust. It's going to go forever and ever and ever down, all the way to negative infinity. And then we're going to go up and up and up and up. And it's going to go this line all the way up to positive infinity. So it's never going to stop. It goes from negative infinity all the way to positive infinity with our parentheses. So for our range, we say that y such that y belongs all real numbers. All right, that's a good amount of practice that we have right now. I want you guys to just relax now and chill. What we're going to have is we're going to have the worksheet doing the domain and the range for worksheet 2.6. It's very, very important, class, that when you do this worksheet, make sure that you have the right answers on the graphs for problems 1 through 8. Because if you have the wrong answers on the graph, obviously the domain and the range is going to be wrong. So make sure you check your answers with me, or check it over with a classmate who also has the right answers down or something like that. And then that way you can finish this worksheet, the domain and the range. We also have objectives 16 and 17. I'm going to hand out these problems, 6, 7, 8, and 9. I'm going to hand that out in class so that we can do that more of an activity where we can get a further understanding of what's happening. So that's what we have. Be sure to let me know if you guys have any questions as well.